Earth is a living, breathing entity, a dynamic sphere teeming with life. It's an interconnected system, a delicate web where everything is linked. Within this web, elements like carbon, the very backbone of organic molecules, nitrogen, essential for proteins and DNA, and water, the elixir of life, are constantly on the move, circulating through the environment. These elements travel in vast, intricate cycles, biogeochemical cycles, the engine that drives our planet's life support systems. These cycles are fundamental, sustaining all life from the smallest microbe to the largest whale. Bio means life, representing the living organisms that participate in these cycles. Geo means earth, encompassing the rocks, soil, and atmosphere where these elements reside, and chemical refers to the elements themselves, their transformations, and their interactions. These cycles regulate climate, influencing global temperatures and weather patterns. They enrich soils, providing the essential building blocks for plant growth, and provide nutrients for all living things, fueling the intricate food webs that connect every organism. Without them, life as we know it would quickly grind to a halt, leaving behind a barren and lifeless world. Our world thrives on recycling, a continuous process of renewal and transformation. Consider this: an atom of carbon in your breath, exhaled just moments ago, may have once been part of a dinosaur roaming the earth millions of years ago. The water you drink, so clear and refreshing, has traveled the globe for eons, a testament to the enduring power of these cycles. Understanding these cycles is key. It is absolutely crucial to understanding our place in nature, our role in this grand interconnected system. They connect us to every living thing, weaving us into the fabric of life on Earth, and ultimately, they connect us to the planet itself, our shared home. But today, human activities, our ever-growing footprint, are disrupting these ancient rhythms, throwing the delicate balance of nature into disarray. To protect our world, to safeguard the future of life on Earth, we must first understand how these cycles work, how they sustain us, and how we can minimize our impact. So let's explore the vital dance of elements, the intricate choreography of nature that makes Earth our home, and understand how we can protect it for generations to come. Two of the most vital cycles that sustain life as we know it are the carbon and oxygen cycles. These cycles are fundamental to the health of our planet, constantly working in tandem to ensure a stable environment. Nature's inhale and exhale, a continuous exchange that underpins all biological processes. It is a delicate dance of give and take. Carbon is the backbone of life, the essential building block found in everything from simple sugars to the complex structure of DNA. It is the key element in organic molecules. Plants pull carbon dioxide from the air through the remarkable process of photosynthesis. Using sunlight as energy, they transform this carbon dioxide, turning it into food in the form of glucose and releasing oxygen as a byproduct, which is essential for many living organisms. Animals eat plants, consuming the carbon-based compounds stored within them. This process of consumption results in passing carbon along the intricate food chain from one organism to another. Respiration, a process carried out by both plants and animals, returns carbon dioxide back to the atmosphere, ensuring the cycle continues. Decomposers such as fungi and bacteria play a crucial role by breaking down dead organic matter. This decomposition process aids in recycling carbon back to the soil, enriching it and releasing it into the air, making it available for other organisms. Over vast stretches of time, some carbon becomes trapped and transformed into fossil fuels like coal and oil. These fuels are locked away deep within the earth for millions of years, acting as a long-term carbon reservoir. Oxygen, a vital element released by plants during photosynthesis, is what we breathe, sustaining our lives. Respiration uses oxygen to break down food at a cellular level, providing the energy we need to function. This process releases carbon dioxide as a byproduct, effectively completing the cycle and returning carbon to the atmosphere. This perfect partnership between carbon and oxygen, driven by life itself, keeps life on Earth in a delicate and essential balance. For millennia, the carbon cycle kept Earth's climate stable, but in the last 2 centuries, humans have disrupted this balance. Burning fossil fuels releases ancient carbon into the atmosphere at unprecedented rates. Deforestation removes trees that absorb carbon while releasing more into the air. These actions have amplified the greenhouse effect, trapping heat and warming the planet. The results? Rising temperatures, extreme weather, melting ice, and acidifying oceans. Marine life and biodiversity are under threat as habitats change rapidly. Our impact on the carbon cycle is reshaping the world. Understanding this is crucial for our future. Water, dew, cycles endlessly through evaporation, condensation, and precipitation. The sun powers this journey, moving water from oceans to clouds to land and back again. Plants release water vapor through transpiration, adding to the cycle. Precipitation replenishes fresh water, vital for all life. Nitrogen, abundant in the air, is mostly unusable until bacteria convert it into forms plants can absorb. These microbes, some living in plant roots, make nitrogen available for building proteins and DNA. Animals get nitrogen by eating plants or other animals. Decomposers return nitrogen to the soil, while other bacteria release it back to the atmosphere. This microbial dance keeps ecosystems fertile. Water and nitrogen cycles are the lifeblood of the biosphere. Human activity is reshaping the water and nitrogen cycles. Dams, irrigation, and urban development alter water flow, causing scarcity and floods. Pollution from industry and agriculture contaminates water, harming people and wildlife. Climate change intensifies droughts and floods, disrupting water distribution. Artificial fertilizers made through the Haber-Bosch process have doubled the nitrogen entering ecosystems. Excess nitrogen runs off into rivers and oceans, causing algal blooms and dead zones. These nutrient surges suffocate aquatic life and threaten coastal ecosystems. Our attempts to control these cycles have created new environmental challenges. Restoring balance is essential for a healthy planet. Not all cycles move quickly. Phosphorus and sulfur follow slow sedimentary paths. Phosphorus, vital for DNA and energy in cells, starts in rocks and is released by weathering. Plants absorb it. Animals eat plants, and decomposers return it to the soil. Some phosphorus washes to the ocean, settling in sediments for millennia. Sulfur, found in proteins, is mostly stored in rocks and released by weathering and volcanoes. In the atmosphere, sulfur can form acid rain, returning to Earth to nourish or harm ecosystems. These cycles operate over geological timescales but are still crucial for life. Even slow cycles are vulnerable to human disruption. Biogeochemical cycles, the intricate dance of elements through our planet, are the very foundation of life as we know it. These cycles, like the carbon, nitrogen, and water cycles, sustain ecosystems and regulate our climate. However, human actions, driven by industrial expansion and unsustainable practices, have pushed these delicate cycles dangerously out of balance, creating a ripple effect of environmental consequences. The consequences are clear. Excess carbon released from burning fossil fuels and deforestation warms the planet, leading to rising sea levels and more frequent extreme weather events. A surplus of nitrogen, often from agricultural runoff, chokes waterways, creating dead zones and disrupting aquatic ecosystems. And sulfur emissions from industrial processes acidify rain, damaging forests and harming aquatic life. The challenge before us is to learn to live in harmony with these cycles, understanding their limits and respecting their natural rhythms. We must shift our mindset from working against them to working with them, embracing a more sustainable way of life. Viable solutions include shifting away from fossil fuels and embracing renewable energy sources like solar and wind power. Protecting our existing forests and actively engaging in reforestation efforts are also crucial. Furthermore, adopting sustainable agriculture practices can minimize environmental impact. Precision fertilization using only the necessary amount of nutrients and regenerative farming techniques, which focus on building healthy soil, can significantly reduce pollution and restore soil health. On an individual level, our choices matter greatly. Conserving energy at home and in our daily lives, choosing sustainable and locally sourced foods whenever possible, and diligently saving water all contribute to a more sustainable future. Educating ourselves and others about these issues is absolutely key to protecting these vital systems for the long term. By deepening our understanding of our intricate connection to these biogeochemical cycles, we can inspire change within our communities and beyond. The future of our planet, and indeed the well-being of future generations, depends on our collective efforts to restore the balance of Earth's critical life support systems. Together, with knowledge, commitment, and collaborative action, we can ensure a thriving and healthy planet for generations to come.